All right, so let's move into talking about integer division. So we can also use chip models to talk about division of integers. So say, for example, we wanted to divide negative 15 by 3. Then what we could do is we could start by modeling negative 15 with a chip model of 15 negative chips. We could think about this with the partition model and divvy up our 15 chips into 3 equal groups. And I could say, all right, one negative chip goes here, one negative chip goes here, one negative chip goes here, and keep going until I pass out all the chips. And I could see that this results in 3 groups of negative 5. So negative 15 divided by 3 is negative 5. Now you might think, what's going on if I need to divide a negative number by another negative number? So let's think about now what happens if we take negative 10 divided by negative 5. All right, so we could think about this as the repeated subtraction view of division. So I could first model my negative 10 using 10 negative chips, and then think about division as taking away groups of negative 5. And so if I ask how many groups of negative 5 can I make out of negative 10, then the answer would be 2, because I can take one group of negative 5, take it away, and then I can have another group of negative 5 and take it away. So 2 groups of negative 5 is the result. So negative 10 divided by negative 5 is positive 2, because I have 2 groups. So the way we define division with the integers is very similar to how we defined division with the whole numbers. A divided by B is the unique integer C if it exists such that A equals B times C. So let's look at a couple examples for this. Okay, so we want to use that definition of integer division to evaluate 12 divided by negative 4. So remember, again, 12 divided by negative 4 is the unique number C, so that negative 4 times C gives us 12. So we would ask ourselves, what times negative 4 gives us 12? So 12 equals negative 4 times C. That tells us that C should be negative 3, because negative 3 times negative 4 is 12. So 12 divided by negative 4 is negative 3. We could also ask ourselves, negative 12 divided by 4. So we would say, again, that's some unique number C, so that negative 12 equals 4C. That should tell us that C is negative 3, because 4 times negative 3 is negative 12. So negative 12 divided by 4 is negative 3. We could also think about negative 12 divided by negative 4. So we would say that's some number C where negative 12 equals negative 4 times C. So what times negative 4 gives us negative 12? That's a positive 3. So negative 12 divided by negative 4 is 3. And then we can ask negative 12 divided by 5. So in the integers, we actually don't have a unique number C that's an integer that would give us 5 times C equals negative 12. So this is actually not defined over the set of integers. So that might tell us that the integers are not closed under division. If we think about AB divided by B, B not being 0, then we would say AB divided by B is some x, where AB times BX, or AB equals B times X. X should be A. So AB divided by B is A, because AB equals B times A. And then Lastly, we have AB divided by A, A not equal to 0. Again, this would be the number x such that A times x gives us A times B, so x is B. So AB divided by A is just B.